properties of exponents. In each one of these three examples below, we are going to be asked to multiply each one of the three terms and then combine like terms. When you're asked to multiply and you have the exact same base, in this case a, I'm going to start by multiplying the coefficients. So 3 times 5 is 15, and 15 times 6 is 90. You're welcome to use a calculator. When you have the same base, a in this case, and you're multiplying, you're going to add the exponent. So I'm going to go 2 plus negative 3 plus negative 7. 90a to the negative 8 if I combined. So we have two separate terms here. 90 is one term, and a to the negative 8 is a separate term. And we're going to analyze the exponents because right now we're being assessed on properties of exponents. So the 90 we say is happy. We're not going to move it because the exponent 1, the hidden 1, is happy. A has an exponent of negative 8. It's not happy, so it's going to move to the bottom. So if I was going to simplify this expression, I would have 90 over a to the positive 8. When it moves down, it becomes happy. Okay, let's do the same thing here with our second expression. 2 times negative 5 is negative 10, and half of negative 10 is negative 5. You're welcome to grab a calculator and take 2 times negative 5 times 1/2. You'd also come up with negative 5. When you are multiplying and you have the same base, you're going to add the exponents. So positive 4. There's a hidden 1, so 4 plus 1 plus negative 2. 4 plus 1 is 5, and 5 plus a negative 2 is a 3. So this is negative 5b to the third. Again, these are two separate entities, or two separate groups, two separate terms. And we're going to analyze the exponent. If you don't see an exponent, it's a hidden 1. So 5 is happy. A lot of students think they need to move it because it's a negative 5. We're looking at the exponent. So 5 is happy, we keep it where it is. The b is also happy, and so if I'm going to take the second example and simplify it, I'd have negative 5b to the third. Let's look at the third example. So in this case, I'm going to take 2/3 times 24 times negative 1. Okay, so let's see what we can do in our head, but you're welcome to use a calculator. So I'm going to simplify, when I multiply these, I'm going to take 24 divided by 3 is 8. So this is 8 and this is a 1. So I have 2 times 8 is 16. 16 times negative 1 is a negative 16. Now, if you would have just taken 2/3 times 24 times negative 1, you'd also would end up with a negative 16. And then C is, when I'm multiplying and I have the same base, I add the exponents. So 6 plus negative 8 plus negative 3. 6 and negative 2, 6 and negative 8 is negative 2, and negative 2 and negative 3 is a negative 5. Okay, think of these as two separate groups. The 16, since we don't see an exponent, it's a hidden 1. The negative 16 is going to stay where it's at because the exponent is positive. The C is going to move to the bottom because it has a negative exponent. So when I simplify this third example, I'd have negative 16 over C to the 5th. Let's look at the next example. So again, we can simplify this. Going 32 goes into itself once, and 32 goes into 64 twice. So the coefficients would simplify to a negative 1/2. Now, whether the negative sign goes on the bottom, the top, or the middle, as long as there's only one negative, works just fine. Remember, you can always take your calculator if you're unsure about simplifying it. In this case, you're going to go 32 divided by negative 64. Find the math key, hit math, and enter twice, and you still end up with a negative 1/2. Again, where does the negative sign go? As long as there's just one negative sign, it doesn't matter if it goes on the top, on the bottom, or out in front. All right, let's work with the A's. So the first three examples we did were about multiplying when you have the same base. Now we're going to work with dividing. When you have the same base and you're dividing, you're going to take the top exponent and subtract the bottom. 3 subtract 7 is a negative 4, so a to the negative 4. And now we'll work with B. The top exponent subtract the bottom exponent. You're welcome to use a calculator. 2 negatives make a positive, and negative 5 plus 10 is a positive 5. I could have also done that using the calculator and taken the top exponent, subtract the bottom exponent, and you can see we still come up with the answer of positive 5. Okay, so let's look now at these two terms. The A right now is on top, but it has a negative exponent. So I'm going to move the A down to the bottom, and now it becomes positive. The B has a positive exponent. It stays right where it is. Some students said, do I need to move the negative 2? We're only looking at the exponents, and if we don't see an exponent, it's a positive one, it's happy. Similar example, we are dividing. I'm going to first just reduce these, and if you're not comfortable by dividing by 3 is 1 and dividing by 3 is 8, so if you're not comfortable to get negative 1 over 8, you're welcome to grab a calculator. And again, in this case, we're doing negative 3 divided by 24, divided by 24, hitting math, fraction, enter, enter to get that negative 1 over 8. Again, where does the negative sign go? Notice there's only one negative, so it can go on top, outside, or down below. Okay, let's work now with like terms. We're going to take the top exponent when we're dividing, subtract the bottom exponent. Two negatives make a positive, and negative 4 plus 3 is negative 1. Same thing with n. Top exponent, subtract bottom exponent. Two negatives make a positive, and I end up with positive 2. M is not happy, so it's going to go to the bottom, and my final reduced answer has m at the bottom and n remaining on. Okay, in this problem we are going to distribute. Now before I distribute, I'm going to look at the exponents. C has an exponent, B does, A does, but I don't see one for negative 3. It's a hidden 1. Now when I distribute, each time I distribute, I'm going to multiply. Negative 3 came from parentheses, so it will remain in parentheses. 1 times 2 is 2. And then I have A, 3 times 2 is 6. And B, negative 2 times 2 is negative 4. And C, negative 3 times 2 is negative 6. Now, the negative 3 is happy on top, and I know this means negative 3 times negative 3. Negative 3 times negative 3 is 9. It's going to remain on top because the exponent is positive. The A is going to remain on top because the exponent is positive. The B is going to go to the bottom because the exponent was negative, and C is going to go to the bottom because the exponent was negative. Let's look at another example. In this example, we're going to distribute the negative 3. But first, I'm going to look inside P. I can see the exponent. I can't see the exponent, so I put a 1. Distribute, and I have 2 to the negative 3. Distribute, whenever we distribute, we're going to multiply. Negative 3 times negative 3 is 9. Distribute, 4 times negative 3 is negative 12. And distribute, negative 2 times negative 3 is positive 6. Making sure I've done my math right. All of this looks good. Okay, so this is not happy. It's going to go to the bottom. When it goes to the bottom, the exponent turns positive. This is happy, it will remain on top. It's not happy, it goes down to the bottom. It's happy on the bottom, it's going to remain on the bottom. What is 2 to the third? That is not 6. That means 2 times 2 times 2. The base times itself 3 times. 2 times 2 times 2 is 8. And I can simplify this to m to the 9th over 8, n to the 12th, p to the 6th. Remember that anything raised to the 0 power is 1. So 2,137 raised to the 0 is 1. B to the 0 is 1. Any quantity raised to 0 is 1.